So we took a look at simplifying radicals where the radicand was a constant or a number. Now we'll take a look at simplifying radicals where you have a variable expression as part of the radicand. So I listed the perfect square numbers. These are the perfect square variables: x squared, x to the fourth, x to the sixth, x to the eighth. You see a pattern there? Again, taking the square root undoes a square. So on number 1, when I'm trying to simplify the square root of x squared, basically you're trying to figure out what number squared is x squared. Sorry, what variable squared is x squared. And that's just x. So the square root undoes a square. Technically, it's the absolute value of x, but we'll just worry about x right now. The square root of x to the fourth is x squared. So if you have an even exponent, you're taking the square root. The easiest thing to do is just take half of that. X squared would be x to the fourth. The square root of x to the sixth is x to the third. Because if I squared x to the third, then that would be x to the sixth. It's just undoing the square. We run into a small problem if we have an odd exponent, the square root of x to the third. But I could break that up. I have to go back to chapter 6 and remember certain properties of exponents. X cubed is the same as x squared times x, because if I were multiplying these, I would add the exponents. There's an implied exponent for the x of 1. And then I could break that up like I do with numbers into the square root of x squared times the square root of x. The square root of x squared, like we saw in number 1, is x. So x root x is what it would simplify to. And then you do something similar anytime you have an odd exponent. The square root of x to the fifth. Here's how I would break that up. The square root of x to the fourth times x. Because the square root of x to the fourth, like we saw, I would need to write it like this first. The square root of x to the fourth times the square root of x. Like we saw up here, the square root of x to the fourth is x squared. And then square root of x is what it would simplify to. And then on number 6, the square root of 80x cubed. So if that looks a little bit intimidating to you, here's what I would do. Break it up. So I would break it up into the square root of 80, kind of treat that as a separate problem, or just work on that first, and then the square root of x cubed. 80 is not a perfect square, but it does contain a perfect square factor. So a perfect square factor of 80, kind of like on one of the other examples that we went over. Yes, a perfect square factor of 80 is 4, but the largest perfect square factor of 80 right here is 16. And then 16 goes into 80 5 times. So right here, what I'm underlining, that's the same as the square root of 80. You can simplify this right now. I'm going to save it until later. X cubed, square root of x cubed. The square root of 16 is 4. So 4 square root 5, square root of x to the third. This part right here can be simplified. The only thing you wouldn't be able to simplify when you're taking the square root of a variable is just that variable to the first power. Anytime the exponent is larger than that, you can simplify it. So what I just underlined right there, I'm going to simplify it. We still have 4 square root of 5. Square root of x cubed, I already did all the work up here. It's the square root of x to the second times the square root of x. This part right here, what I'm underlining, can be simplified. Maybe you write it like this first. 4 square root of 5. Once you take the square root of x squared, it's just x and then square root of x. Here are the two things that are outside of the radical, not underneath the radical anymore. So I'm going to combine them, 4x. These two items right here, the 5 and the x, are both underneath the radical, so you combine them to just one radical. 4x square root of 5x is what it should simplify to.